So on the test, most of the time it was just little stuff like writing down 8,000 instead of 10,000, and writing down 30 days instead of 80 days. And let's see, there was some other thing I was going to point out to you. I think some of you did this wrong. I think it was a calculator issue. The effective rate is the dollar amount of the interest divided by the dollar amount of the proceeds times the time. And I think some people, when you put this in your calculator, it wound up looking like this. That's not the same thing. Okay? Trust me, it's not. So, be careful. On that in the future. Okay? Well, let's do a little work. Today's the 30th day of October. Tomorrow will be officially Halloween. So, let's, by the way, if you have any questions on the exam, you know, after you look at the key, you still don't know what happened, let me know. I can go over a problem in class, or I can explain it to you individually, whatever it takes. And as I pointed out, for the most part, it was just little simple things. There may have been only one problem that somebody went totally off the rails on, and they got at least part of it right. So, pretty good work, I'd say. So let's look at chapter 11, or excuse me, chapter 12. 12 is on compound interest. And more specifically, things like future value and present value. And I'll just go on and define future value. How about this? What's some amount of money I'm going to use the word invested at how about a certain interest rate will be worth at a certain time in the future. That's why they call it future value. So in other words, if I said, okay, you have $10,000, you're going to invest it at 3% for 5 years, compounded quarterly, how much is that going to be worth in 5 years? We can figure that out. Okay? So future value is part of it. Another part of this is present value. And this is different than future value in that you start off, the question is what amount of money I'm using the word invested here, but for the most part, we're talking about putting this in a bank. And that's, I guess that's a form of investment. I guess we could just put banked in there. What amount of money invested now? I should rewrite that. How about, I'll put all the words in, we'll see if they make sense. Is required to, how about yield a certain amount in the future. I'm not sure that makes that much sense. There's a difference. With future value, you know what you're starting with. You don't know what you're going to end up with. Present value, you know what you want to wind up with. The present value is what you've got to start with. Okay? So with both of these, we're dealing with compounding, and I'll talk about that here in a moment. So on these, you just want to think about what you don't know. For example, with future value, you know what you're starting with. You don't know what you're going to end up with, so that's future. Present value, you know what you want to wind up with in the future, but you don't know what you're starting with, so that's the thing you're looking for, the present value. And both of these are based on like the concept of compounding interest. Okay? So let's talk about compounding interest. And to do this, let's do this. We've looked at simple interest. And this is typically what happens if you are, well, the loans we've looked at so far are simple interest. The interest is calculated at the end of the period of the loan or note, etc. Now think about this. So far on simple interest, we've just calculated the interest equals the principal times the rate times the time we did it once. Now, I know you're sitting there thinking, well, what about this problem on here where there was partial payments? Yeah, but it's still the same concept. Remember I told you, as far as I was concerned, partial payments is just like you start another loan. At the end of it, whenever you have a payment, to me, it's like, okay, that loan's over, you're starting another loan. So the interest is only calculated once for each of these. Now let's look at compound interest. With compound interest, the interest is calculated at intervals throughout the loan, and oops, I said one thing and wrote down what I really wanted. And this interest is typically added to the amount whenever the interest is calculated. Now here's the tricky part. Well, here's the interesting part. Therefore, the next time, let me fix that. Next time the interest is calculated, it is based on the starting amount plus the accumulated. Can I spell accumulated? So here's the beautiful thing about compound interest. For example, I mentioned a while ago that maybe the compounding period is quarterly. How many quarters are in a year? Hello? 4. That's why it's called quarter. Semi-annual is twice. You can do monthly. You can actually do daily. There's not that much difference between daily and probably quarterly, but it is possible to do. But as you go along, at the end of every period where the interest is calculated, whatever interest has been earned is typically just added to the amount that was already there. So the next period you get interest on your interest. And next period you get interest on your interest on your interest. Okay? This is the process of compounding. And it's fairly amazing. See, if you look at the bottom of page, well, there's one on 304. Those of you who got your book. Down in a footnote there, there's one there that says the formula for compounding is A equals P times the quantity 1 plus I raised to the n power. Actually, we're not going to do that. I'm just pointing out there it's there. There's another one in here that's even more scary. There's one on 309. Present value is equal to, what is that? The amount divided is equal to the amount divided by 1 plus your interest rate raised to the n power. So there are formulas for this, but guess what we've done? If you look on page 305, does everybody see table 12.1? Y'all see that? Everybody, how many people don't have their book with them today? Y'all don't have a book? Is it online? Yeah. It's got to be. Otherwise, you couldn't do any homework problems. You want me to call it up on mine, or y'all okay? Because everybody got something they can look at and say, oh, I see what they're doing, or I see what the table looks like. Well, I can call it up too, I think. By the way, and this is in the book, this is page, I guess, 301. It does go through an example here of this whole idea of compounding. And in their example, let me turn this back on. This is page 301 in the book. So their little example here, you start off with $1, and they're doing this at 8%, which is, like 1976 numbers. But at the end of a compounding period, now they're doing this every year. At the end of the first period, you'd earn 8 cents on your dollar. Well, that gets added to the dollar. So at the end of the second period, you've got $1.08 is what you're calculating your interest on. So next time you earn 9 cents, I'll round it up, and then that's added back in. After 3 periods, your investment, well, your interest is worth 26 cents, and that gets added to your, that's going to be added to your original dollar. So you'll notice here after 4 periods, 4 times 8 would be 32 cents. But with compounding, you're up to 36. Okay? And the longer you leave it in, the more this effect kicks in, earning interest on your interest. So I'm not going to go into a whole lot of detail on that. I'm just going to tell you how you do this.
It's a really smart thing for these younger people
Yeah.
to do.
Yeah.
I mean, it can really save you in the long run.
Mm-hmm.
I mean, it's a really easy, great way to have money when you get older.
Here's what we're going to do, and let me, based on what Gretchen said, let me show you something. It always amazed me. I'm going to give y'all this rule of thumb, and that's the only thing y'all remember for the whole class. And it amazes me. The amount of time for an amount of money to double. Now this is this is if you got it invested, either in a bank or in the stock market or whatever, is about 72 divided by the percent. So for example, at 4%, it's going to be about 72 divided by 4, which is 18 years. So what Gretchen is saying is, if you're young, say you're 20 years old, you invest some money at even 4%. Time you're 38, it will have doubled. And then by the time you're, 56, it'll double again. So even at 4%, it only takes about 18 years. This is approximately. And you can use 72, or some people just say 70. But
Or would it be 0.04?
No, just do it like this.
All right.
Use the whole number. Don't turn it into a decimal. Just put the 4 in there. Okay? So this is the amazing thing about compound interest. So let's go back over here. This is on page 304. Make a note here. This is how we're going to do this. And this is future value. Here's the steps you follow. Step 1, find the periods. And this is going to be the number of years multiplied by the number of times the interest is compounded in a year. So if I say 10 years semi-annual is twice a year, times 10, that's 20 periods. Okay? Find the rate. Now this is the annual rate divided by the number of times the interest is compounded in a year. So if I said 10% semi-annually, that's 10 divided by 2 is 5. Okay? Now we go to the table, 12:1. So you go down the period column to find the number of periods and go across. till you get the desired rate. And where that intersection is, there's a number, and this is the table factor for a compound amount of $1. So you simply get the number here and multiply that times the number of dollars you start with, and that will give you your future value. Let's do one. I'm just going to get one out of the book here. I'll write down all the particulars, and you'll know what I'm looking at. I'm going to start a new page. So this is problem 12.2. Now, getting back to what I was telling you a while ago, I showed you what there is a mathematical formula for this. But what's happened here is somebody's gone through and worked out the formula for these table values. Okay? Now, what you see in the book is an abbreviated table. There's another, if I can find mine, there's an external, here it is. If you buy a hard copy of the book, you probably got this as well. Did y'all get this?
Yeah.
Okay. There's more expanded tables in here. Okay, so if there's a number that you can't find in table 12.1, check this. Okay? So let's look at 12.2. If I can keep this daggone hook from slipping off into the floor. So here's the particulars of 12.2, and this is page 315. You are given time equals 12 years. Principal, this is what we are investing, is $15,000. Rate is, that's 3.5, isn't it? Yeah. Okay. Annually. And we want to know what happens at the end of that. So this is future value. Now, if you look at table 12.1 and recall the instructions, it says you go down to periods in the column on the left, and then you go across the row till you find the percent. Notice those have not been turned into decimals. So if you're going to get it out of the table, you don't even have to turn it into a decimal. You just got to be able to divide properly. So anyway, let's go back. Read our instructions. Step 1, find the periods. This is the years multiplied the number of times the interest is compounding in a year. Now this first example here, I don't know why they started off with this. Annually means once a year. So the periods is going to be equal to 12 years times 1 period per year. And y'all know how much I like to cancel things out. That's what happened to the years. That's where they went. They canceled out. So we're going to have 12 periods. Usually it won't be annually. It'll be semi-annually or quarterly, etc. But anyway, that's how you do it. Now, what's the next thing it says to do? Step 2, find the rate. The annual rate divided by the number of times the interest is compounded in a year. So let's do that. So this is step 1. This is Step 2, you want to know the rate per, what you're really doing is the rate per period. So what we have here is 3.5% per year times divided by 1 period per year. I'm just showing you the math. After you look at this, you don't have to do it anymore. But every once in a while, I just feel compelled to do a little math. This is a complex fraction, isn't it? To simplify this, you invert the denominator. So here's what you're going to have. You're going to have year over period and then year over period. Remember how to simplify a complex fraction? And the reason I did this, the thing I added here, the year divided by period divided by year divided by period, that's equal to 1. So I haven't changed anything, but watch what happens here. That cancels, that cancels, that cancels, that cancels, and that cancels. So in this case, we're left with 3.5% per period. I just wanted to prove to you that the math works out. Now, you don't have to do that anymore, okay? I don't want to traumatize anybody, but that's the way it works. So that's step number 2. Let's go back to our instructions here. Step 3, go down the period column of the table to the number of periods desired, look across the row to find the rate at the intersection, get the number. They call it a table factor. So, step 3, from table 12.1, 12 periods. I don't know why I continue to write in red, or blue rather. Let me fix this. So from table 12.1, we have 12 periods, 3.5%. Is 3.5 in there? Table factor equals. So go to 12.1, and hopefully 3.5% in there. If not, we're going to have to go to our other book right away. Why would they ask a question and not have the answer in there? How many people got this other book? Well, how many? Let's see. Can we look on with each other? Bex, you got yours?
No, I don't have it on me.
I know, but I just want to show you how to read it.
Yeah.
Well, here's the way this works. I'll show you, and then we'll go over there. There's a table where it says 3.5%. Notice, this is an extension of table 12.1. This is whole column. This is 12.3. This is 13.1. We'll get to that later. So for this example, go to the page. This 3.5. We're working off of table 12-1 in the other book. So it's this column. This comes down to 12. Read that. How many? Did you see how I did this? Did y'all see how I did that?
Yeah, no, 5%.
You're not gonna show y'all.
I'll be there in a minute.
Thanks.
All right, 3.5%. This whole column here is an extension of table 12.1. This is an extension of table 12.3.
No, this 3.5%. Yeah.
So get the right percent.
12 periods.
Okay, and you go down and read the number of periods in that column. So it's.
Oh, yeah, you're right. 12.1.
Okay.
You're right. That's 3.5%, 12 periods.
Now again, there is a mathematical formula we could use, but hey.
It'd be 3.5, 12 periods of
Yeah.
compound value, right?
1.4.
4, 6.
No, that's 11. above is 1.1511111.
Yeah.
Okay.
So the table factor for this is 1.511. Is that enough ones? Or is there another one? There's 3 ones in there.
Yeah, I can't keep. I can't keep.
111. Yep.
Like,
All right. Now we got all the information we need. Go back to step 4. Multiply the table factor by the amount of the loan. This gives the compound amount. Now they call this a loan. This also works for putting money in the bank. Okay, I don't know why they put loan here. I would have used a more generic term. So step 4 looks like this. 4, the future value is going to be equal to, what was the principal? 15,000? 15,000 times 1.5111. Calculator. So we don't even need a calculator until we get to step 4. Calculator, 15,000 times 1.5111. Enter. So here's what we found out. $15,000 invested at 3.5% compounded annually will be worth $22,666.50 in 12 years. That's what we found out. That's what this little calculation did for us. And if you want to know the interest, what would you do? The interest is the future value minus the principal. So 22,666.50 minus 15,000. The interest accrued, I think, is the word we want to use, over those 12 years is $7,666.50. Now here's what I do. I would look at this and say, well, wait a minute, 3.5%, that's between 3 and 4. If it was 4, divide that into 72, 18 years, it would double. If it's 3 into 72 is 24. So you'd expect this to double, within 21 years or something. So the 12 is about half that. And look, $7,000, $7,600 is about half the original 15. So I like my answer. Okay, it makes sense to me. I just looked at the rule of thumb and did a little calculating in my head, because we're about halfway through what I would consider the doubling period. Okay? Do you see what I did there in my head? Actually, you can get the doubling period from the table. Anybody have an idea how to do that? You'd simply work backwards. You'd find the values in the table that are 2 for like a particular, like if you look at 4% and go down to 18 periods, your table factor is 2.0258. That's going to double it. So at 4%, it takes 18 periods. That's exactly what I said a while ago, wasn't it? That's the rule of 72. It's amazing, isn't it? It's right there. Anyway, this last part of what I was doing in my head, I was just calculating, make sure my answer looked reasonable to me. Okay? I put a lot of stock into reasonableness of answers. Okay? Now, that wasn't too bad, was it? It's just like 1, 2, 3, 4. Let's do another one. A little more complicated. Let's see. How about 12? I think I'll get another page. Problem 12.4. We're still on 315. So let's see. T equals, oops. Only 2 years this time. Principal's still 15,000. And rate is 8%. And it's compounded quarterly. Okay, now, just like before, step number 1 is figure out how many compounding periods you're going to have. So the periods, change colors. The periods is going to be equal to 2 years times 4 periods a year. Why did I do 4 per year? Because it's quarterly. Now again, years cancel out. So how many periods am I going to have?
8.
Okay, 8 periods. So that's step 1. Step 2, we need the rate per period, and it's 8%, and there's 4 periods in a year. So this is the abbreviated version of what I did a while ago, but we should all understand now where it came from, so we can just do this, can't we? So what's that going to be per period? 2% per period? All right, everybody okay with it so far? Now step 3. You look this up in the table, don't you? That is step 3, isn't it? From table 12.1, 8 periods, 2% per period. We're looking for the table factor, and you can find that in the book or online. 8 and 2, what'd y'all get?
1.1717.
That's what I got. 1.1717. Let me make that a little prettier. Years ago when we ordered this desk, we ordered one, and the guy with the money looked at it and said, let's order a whole bunch. and he did this before anybody ever tried them. These are the most uncomfortable things to teach off of if you're trying to sit down. They are. It's awful. Anyway, so that's our table factor. Now what? Step 4. I keep doing that. I like the blue, but I like the red better. Future value is going to be $15,000 times the table factor. Calculator? Y'all work that out. I'm going to copy this back onto the previous page real quick.
So do we need to print out this table?
For tests? That's a good question. I guess we need to figure out how many people have books and how many people don't. If you have a book, it's in there.
They only bought the copy at the bookstore. We could only buy the hard copy with the digital.
Yeah, well, this is what I was talking about.
Yeah, that came with the hard book.
So we need to figure out how many people have this and how many people don't. I've got this one. I can't remember if I got another one or not. There may be another one floating around here somewhere.
I mean, like at home or something, we can just print out this one green table.
Well, at home you can just get it right off of. Oh, you're talking about the weird little things that aren't in the table that's in the online book. I'll try not to assign ones that turn out, but you got to look them up that way. It's somewhat hard to do. Let me write this down real quick, and then I'll look something up. So I've got 17,575, 50, and then let me do the interest real quick. Then I'm going to check something. The interest is the future value minus the principal. So that's 17,575, 50 minus the 15,000 we started off with. So the interest you earn in 2 years, compounded quarterly, at 8%, which is a very high rate, actually, is going to be $2,575. And 50 cents. Let me copy this and I'll look something up. Do y'all find these little screenshots helpful? Okay. Let's look on the internet. There are future value tables out there on the internet. This one's got half percentages up to 3. It's got quarters up to 1, and then halves to 3, up to. Okay, but this is a pretty good one right here. I just did a search on future value tables. So I'm pretty sure if you have the internet, you can, find something that'll provide you the answer if you're doing homework. Okay.
You just have pulled up these, so it was a-
The big thing is know what you're looking at and how to figure out the periods and, you know, the interest. So we just looked up, it was how many periods? 2 years, be 8, and we were what, 2%? This actually has another decimal place. This one says it's 1.17166. The book rounded it off to 1.1717. So this one online has another decimal place. Anyway, it's shouldn't be hard to find what you need once you know what you're looking at. But of course, before today, you looked at this and you didn't have any idea what this meant, did you? Okay, so boy, y'all are smarter already.
This one doesn't have it like the book has it though. It says future value of $1,
Yeah, that's what the book does.
but it's got it rounded because for the 8, it's got 1.17166.
Yeah, the book's rounded off. This has got an extra decimal. So, that's all right. You'll be okay with either one of them. So find one that you like. That one doesn't have halves. Now, there are calculators. Says you can print the table there. You can play around with how to use these. I don't really go over these. Somebody just wrote a computer program to do this for you. I think it's nice to know the mechanics of how to do this rather than just plug some numbers in some holes. Of course, we already are taking the shortcut version of this because we're looking at a table that somebody else has already prepared. This is just a computer program that does the same thing. Okay? It'll work out this formula. So anyway, let's hopefully I'll remember to assign some homework. And next class we'll look at present value. And the present value works the same way. You just use a different table. Okay, we like that, don't we? Nothing new to learn. We just have to make sure you get in the right table. Okay? All right. Happy Halloween.